Okay, I think that's the signal, my cue. Okay, so we start. My name's Hansi, and I would call myself mostly a programmer, just to know sort of where I put myself. Thanks for Matthias for inviting me, thanks for being able to be here. My plan today is to finish a bit early, so we have a little break before the next talk. And I want to spend around 15 minutes to talk about other things I do, sort of my past, so you know where to put me and things that interest me and how I work. And then I'll talk about sort of the big topic of the talk, like why every squiggle is a synthesizer, which is sort of this deep, long, accidental rabbit hole of oscilloscope music, which Cherubin Fenderson and I fell into. If there's questions that come up, feel free to interrupt me. If I know it's going to be too long, we might postpone it to the end. But I don't mind sort of being asked the question in the middle, especially if something's unclear or if something seems wrong or my terminology might be different than yours because I don't have this extreme music background. So feel free to interrupt. Okay, so let's get into it. I had sort of the fortune of growing up just in the age when computers entered households. So this year I have my 25th anniversary of programming, like a long time for being 37. So I programmed all my life basically, and when I was 20 I ended up in this place called Fabrica, which is a weird place run by Benetton where you can sort of mess around. They give you a little bit of money, they give you an apartment, and you're supposed to produce things that make them look good. You know how this type of companies operate. So for me it was a great time living in Italy for a year and just playing around and coding random things, and then actually they would be used. So this is one of the things that I did. It's a chat for it was a website, but you couldn't use words, so you could only draw, and you could take someone else's drawing and draw on top, and within a few months people made millions of drawings and they went crazy for it. It's not online anymore, of course, because this was in 2006. But it was quite interesting to observe what happened. Like people would, for instance, start playing games of tic-tac-toe. Like the first person draws a grid and then the other person copies it and that's a ring. So that's the type of thing I did there. It was called the New Media Interactive Department. And one of the bigger things that I did was I suggested to make. I'm sorry for the quality of the video, but that's how it was at this time. I suggested. So there was a big anniversary. Benetton turned 40 years, and they rented the Centre Pompidou, and they asked everyone to sort of propose something. So I proposed to build this stairway, which worked like a piano. So it was a little xylophone on every step, and there was a pressure-sensitive mat. So when you walk down in the space, you would sort of play a little melody. And at this time, I have to say, so I also really like to talk about failures and errors I made. So at this time, I was too inexperienced and I was always trying to go low budget. So I was trying to make the resistive mats, for instance, from aluminium foil. But I forgot that Benetton is a company that doesn't care about money when you do this type of thing. So they actually built us to do this, a replica of the stairs. Like they rented a warehouse and built the stairs, and then they just bought the mats. And so in the end, it was produced by one of my colleagues. But it was an interesting experience this whole year, to work for such a big company. But I also knew. In this year, I think I discovered I don't really want to be part of a big institution. Like, you also have a lot of constraints, and you're always pushed in a certain direction. So after I continued my studies of mathematics, which I started before, and then I never finished. To this day, I haven't finished. I was subscribed to university for 12 years, and I didn't finish. But I really enjoyed, and I think I took a lot from it. I also looked into a lot of other studies. So, you have to get by somehow. So I want to show one of the things that I do to get by is, so this type of staircase lifts that go along the staircase for disabled or old people. So that's a typical job I would take. Is there's this company, they make these and they have this form. So someone calls and says, I'm interested in a staircase lift. And then they have this form that they write down all the details, like which type of lift do you need, and then we talk, and I get these diagrams, and I try to understand the company, and then we make very boring but important software, which looks, like this, and it helps them. So the reason I want to show this is because for me it was always clear quite early that I can get something from this type of work, like two things at least. One is money in my account and it pays my bills. And the other is it really forces you to sort of work with a type of precision that maybe you don't want for yourself. It really needs to work. Often I find when you make something for yourself, like a little test, then you're satisfied very quickly. But when you work for someone else, you're always forced to flesh it out and finish it and really round it off and polish it. So I've always liked this, and to this day I do this. So I want to show one second commercial project which started in 2016 and is still going on. So this is for Audi, the car company, and so they have this problem of really wanting to have like an identity worldwide, and so they have people who make ads like this, people running on the beach, everything's very happy. And then there's this point where you need to add the logo and the signature sound and all of this. So that's a software that Andreas from Kasuga, he lives in Berlin and we work together quite closely. So we make this software together, and the idea is you take this video, like any clip you made already, and you put it in, and it does everything. And you can't make any mistakes, so it has all the different translations. You cannot mistranslate, you cannot misplace the logo. And I really don't mind this type of work. I always felt that it frees me to then in my other time do whatever I want. So I'm gonna show some of those other things that are whatever I want. So I've always had an interest in sound, and this is one of the things that came out of Fabrica. I was invited later to participate in a workshop by Zach Lieberman. I don't know if the name rings a bell. He's quite a known media artist. And that's sort of what dragged me into C++ programming. And I know it's maybe getting too convoluted, but it's sort of, if you want to do low-level audio programming, you need a very fast language. You can't waste much time if you want to synthesize yourself. So this workshop really dragged me in, and he showed a really small example. Like he showed sort of an example where you could draw a line on the screen, and he set it up so that on this axis you had the frequency or the pitch, however you want to call it. And here. Sorry, yes, thank you. So I think the square you understand. So we have some squiggle. So we have the frequency going up and down and the pan going left and right. So that's left channel, right channel. So this squiggle would make a sound like whoop. And he just showed it as like an example of how to connect unrelated properties, and then he moved on to the next. But I sort of fell in love, and then I did what I learned. I fleshed it out, and I'm gonna show maybe 1 minute of a review. It was lucky because at this time the iPad just came out, and I was like, this needs to be on the iPad. Danke. So the way the program works is you have sort of here triggers at different speeds, and here you have different very fundamental wave shapes like sine and triangle and rectangle, and here you have some stuff like load and save. So you can make this whole mess, and it has a little bit of a concept of rhythm, but it doesn't have a concept of bars or of a composition. That's the sound, it's not someone making fun. So this was quite successful, and people really liked it, and so it encouraged me to play around a lot more. So the next thing I wanted to, I'm always obsessed, and maybe it's not a good drive, but I can't help it. I'm always obsessed with how things work, and sort of how is everything made. So the next thing I wondered, and this one I never finished it, but the idea was, well, if you look at this, like your hand, right, and you look at the fingers, and you connect them, then you already have some sort of crude waveform. Like you can already see, like, yes, it's a waveform. So I tried to make this synthesizer called Finger Baby, and I'm gonna show a short clip. So you can see all these like fundamental things about music, or like about synthesis, like when the wave becomes wide, it goes low. To make it sound a little bit better, I mirrored the shape after, so it's not as terrible. And sort of my vision at this time was like, so when you play something like a stage piano, you control a lot of things with your fingers. Don't get any wrong ideas, I don't know how to play the piano. But I was thinking like you control a lot of parameters, but you're always in a way mostly on the sequencer end of things. Like you're mostly inputting tones, and you can do some things like I think with your feet. But my vision was like, maybe you can play the piano with one hand and make the shape with the other hand. So to restrict yourself to solo runs. And so I'm gonna show like a stupid video where a friend of mine and I just mess around with it, and he has the arpeggiator feature on because he also doesn't know how to play the piano. So it was really intriguing for me, this like very direct manipulation of the waves. Like really, what is this, the sound? Not in an abstract sense, but concretely. Like what's the shape of the wave that's made? And I think with this, my problem was I got lost in details. Like I really wanted more and more. You can already see I have 2 of them going. And if I show you like maybe the latest version that I had, I was thinking like, I want them to move automatically to add some kind of Schwingung, a beating effect. So I could produce sounds like this, which I really liked to be able to do this. So here you can also see that at this time I had a huge interest for the Bayan type accordion and this layout. But so it's a project that went nowhere really. And It happens, it happens. I'm gonna show, I think, before we depart, maybe one more thing from the music domain. I'll show you 30 seconds and then explain. So that's 2019. Oh shit, sorry. My computer's gonna crash if I don't close this. Okay. So the whole thing is 3 or 4 minutes long, and I'm gonna skip to the second half. Okay. So you can watch the whole thing on YouTube. So I want to explain a little bit what you're seeing here. I have this obsession since a few years with like manufacturing and robots. So I think it must have been 2018. For Christmas, I got myself this like tiny robotic arm. I was like, what can I do with this now? So I made this little attachment, and it has two tools. One is a vacuum suction, so I can take the seeds from the basket. So this is a bunch of grass seeds, and this is a needle, and it's connected to like a water pump, and I can put single drops. So the video in a way was a lot of preparation, and the setup really looked this weird. It was only in a dark room. And then when you take a picture and you set the camera nicely, it comes out like this. And it ran for 6 or 7 days, like automatically. And then I used sort of the commands to the robot and turned them randomly into MIDI notes. And the big part of this is the music. And we were undecided about because at this point you just have beep, boop, 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 boop. And we were undecided what to do with the rest of the sound. And I think after 2 or 3 months I got desperate, and I just asked a friend, do you have some time to teach me Ableton Live? And so we just had a lot of of fun doing stereotypical things, and in the end we weirdly won a prize for the music, not for the video. But that's how it goes sometimes. Okay, so I think with this you sort of know a little bit my universe. Are there any questions so far before I go into the oscilloscope? Okay, so again here I want to give a little bit of a... No. Okay. I want to give a little bit of a backstory. So this was also a project that was commercial work in 2013. And I was asked to make... The idea was he wanted to sell tables with print on them. I don't know why, but it was his idea. I was like, yeah, I'm happy to research, because he really wanted to have nicely rendered previews of how your product is going to look. And of course, every product is different. So you need to somehow render, and it was 2013, so things were not so easy. In this project, I mean, it was a complete failure. At least the part that I was responsible for sort of worked, but the project as a whole also failed. But during the research phase, I looked at, I think, most available 3D programs and how to render. And in the end, I decided on Blender, and it turned out to be very lucky, because first of all, I really started liking Blender, and I made a lot of designs for random reasons. Like, I just really started to get into 3D modeling. So this is a a device you can put into people who snore a lot. So it solves, it solves the concrete problem. I did random things like this. It's supposed to be a cuttlefish. And then I made this website with devices for like this weird combination of social media and dying. So I modeled all these, like I badly modeled all these things, like this is a chip you put here, and then it has a sort of like on your bike, like it's driven by your bloodstream, and if it stops, it like sends a text message to all your accounts. So, I mean, I really didn't care, I just liked modeling, and I was like, okay, let's make random things. But again, then that's how things sometimes come together. Because you're from Salzburg, you probably all know Schmiede, which is this festival, it happens once a year for 10 days. And I met Chris, the Cherubim Fenderson, and he was already, I think, 1 year into this journey of making music specifically to show them on the oscilloscope. Quick show of hands, who knows what an oscilloscope is? Everyone. Like, everyone. Okay, so I don't explain it. It's good.
I don't know what that is. I don't know.
You don't know?
Yeah.
Okay, for you, I'll explain it very soon.
Thanks,
No problem. So he really had a background in electronics, like he worked as an electronics engineer. He used oscilloscopes on a daily basis, but he was bored and he really was into music. And so a year before I met him, he started to experiment with, I think he used mostly MaxMSP and Pure Data at this time. Like how can he synthesize stuff that looks interesting? And so I'm gonna show you what he showed me when I was introduced to him. I'm gonna let it run for like a minute or so. Okay, so I'm gonna explain a little bit what's going on here. So the oscilloscope is really, we have one here also. It's a measurement device and it shows the voltage, sort of the potential. If you don't have any other connection to this, it's like how full a battery is what it measures. And it can show you this in various ways. And one of the ways it can show you this is called XY mode, where you require two inputs, and those two inputs can move the dot around. So if it's, say the battery is very full, the dot will move to the right when you connect it. And if it's your reverse polarity, it goes to the left. And you have two channels, so one moves the dot up and down, which is maybe this one, and the other one moves it left and right. So it seems kind of natural, to me at least, to use this and put stereo music on it. It's actually, I think most serious audio programs have this view because it shows you how spread a signal is, how much stereo you have in your signal. So what you have to imagine is this process is very fast. You can move this tens of thousands of times per second, and then you lose the dot. It becomes lines and all kinds of shapes. And if you think about the mono signal, so the left and the right channel are exactly the same, well, then you're going to move along a diagonal axis. But say you reverse the polarity of one of the channels, then you're gonna get a flipped axis, which that's usually the worst thing, and you never want this for multiple reasons. But if you play with this, you can get very nice shapes out of this. And I'm going to show the basics, and then even though most people know it, I'm still gonna show the basics to maybe give a different view. And for this part, I really like to use Audacity because I think everyone touched it at least once, and it's sufficient. You can do a lot of things here. So one of the things that it has is it has a tone generator. Again, we're very sort of low level. We're just generating a sine tone, and I'm gonna put it at 250 hertz, which is very pleasant. Let's listen to it. So this is what we get. And we're still doing mono, so it's diagonal. And let's move it to the left channel, and you can see it's up and down. If you flip the two, you can of course always flip them. There's no definition of what's right. You get a horizontal line. So to make things interesting, what you want to do is you want to generate another tone. For instance, at the same frequency. Oh, I think I messed up. Let's do it again. And we pin it to the right channel, and let's press play. So we are mono again. The signals are identical. So let's zoom in and see this. And things get interesting when you put them. It's called out of phase. So you put them out of phase a tiny bit, and it becomes this ellipsis. And then you're already playing. Like you're already sort of in this game. You erase exactly a quarter of this sort of repetitive sine wave, then you get the perfect circle, and I did it almost perfect. And you can already in Audacity, you can go quite crazy with this. So for instance, you can generate a tone that's a tiny bit off, like 251. And now I don't even need to erase anything because they're gonna run apart and together all the time. Like if you look here it's exactly they're exactly the same. So let's go further, but you will see that they have this drift effect now. Here they're opposite. So this one's extremely plus, this one's extremely minus. So if you look at this now, you get this effect where you have a wobbling circle. And so I never tried this, but I made two apparently. But I think you might already get some interesting effects if you play a little bit with the amplitude. So let's see what happens. It's not so interesting actually. It's actually not interesting. But what's very interesting is to take multiples, especially whole number multiples are very interesting. So let's go 500. Let's go 501, so we get this wobbling effect again. Pin it to the right. Let's see what we get. So we get the figure 8. You can of course also put multiple of this on a single channel. So on the left I could maybe add, I don't know what could be interesting. Maybe we add to 250 the half, which would be 375. Let's see what happens. What can happen? So I also put it on the left. So we're a bit too loud. But you already get a quite intricate shape. So this is of course called additive synthesis.
you take a bunch of waves and you add them together, and that's what you saw here. So that's what you saw is basically an additive synthesizer, where during the construction of the synthesizer you really pay attention to the phasing, which is often ignored or not, so people don't care so much. But if you pay only attention to the phasing, then you can get these beautiful things out of very simple ideas. So you can get it either out of programs like Audacity, MaxMSP, Pure Data, pretty much anything you want. But you can also get it out of a simple analog synthesizer. It becomes a bit more painful with the phasing, but it's possible. And there's people, I just realized I don't have him anywhere on my slides, but there's people like Bernhard Rasinger, if you ever, and he goes by BR Laser when he plays. He does this, and he uses a laser, which is a completely different device, but it fundamentally works the same way than an oscilloscope, and you can put also directly audio signals, and that's what he does. He really uses a modular synthesizer for this, and it requires a lot of patience, but I think he does very nice shows. So if you have the chance to do this, catch it. So one thing that you might notice when you think about sort of this relation between the single wave on each channel and the shape, then you start to realize that you can actually have a video for this. You can reverse this process. You can do the process the other way around. You can first think about the shape, and then from this you can construct the wave that you need to make this shape again. So you go in a circle once, roughly. So I have this demo video that tries to show this, and I'm gonna pause it in a second, if I'm able to. So that's a program I made just to demo. So the yellow lines here denote sort of, yes, I'm gonna pause right here. Oh, I was too slow. So what you can see in this program is you draw a circle, and then it shows you, so on the x-axis you need to move in a sine wave. The graph is also flipped. And here you need to draw this, which I drew it badly, but it's also a sine wave shifted. With this you can sort of experiment and see how the waves on each channel need to look for different shapes. So for a spiral it needs to squiggle up. Yes, for a triangle you need something like a triangle. For a rectangle you need sort of trapezoidal shapes. So this really sort of allows you to systematize the output of your waves, and it's really a very different approach where the visuals control the audio, but they do it on an extremely low level, really directly on the signal level. It's not an abstract relationship, it's really concrete. And so when we play live, this is also really exactly how our setup looks. We have an audio interface, and we go left channel goes into the speaker, right channel goes into the speaker, and then but left channel and right channel, they also go into the oscilloscope screen, and it's the same signal. And usually you have a choice. Either it sounds shit or it looks shit. And there's sort of these small islands of interesting shapes. So to tie it back to this project which I mentioned before, this project, like a year after I met Chris, we met again, and then all of a sudden it clicked, like, oh, I can
I can systematize this using Blender. Like I learned so much 3D modeling, and in 3D modeling, of course, you always deal with some kind of geometry. So the idea was, if you say you have a model of a cube, right? And that's your 3D model. Then if you can sort of follow it with your finger some way, and you start to notice, oh, how do I do this? Like, is there a system? Or do I randomly need to go? And so I'm trying to do this, and you see here, oh, I was already here, but who cares? I do it again, because I'm still missing some parts. So that's the game. You try to trace it with your finger, and if you can do this, you get the wave. And if you get the wave, you have music. And it took only like 4 days or something to sketch out the very first prototype of this. And I was excited because after a few days I got this result. So, I mean, of course, it's your choice if you think this sounds shit or not, but I'm happy with this sound. And I knew it was something that needed to be looked into further, and so we've been looking into it ever since. So this was 2014. And so how to continue from here? So I want to show you an excerpt also of so Chris, out of the two of us, is certainly the better composer because I'm not. So I want to show you an excerpt of a thing that he made using this technique, and I'm gonna explain a little bit more about the technique, but first this. Okay, so it goes on. I show you 5 seconds of the end. And so on, and so on. In the end, we made like a full album of this, and it turned out quite successful. So it was nice. We got to play a lot of concerts and got to see a lot of nice places. And I think the last year, especially like since Corona, we got quite lazy, and I think it's okay in the context of like a 6-7 year project to be lazy for a while. So there's 2 more things I want to mention. One is really that it's sort of, for me, this connection, this type of idea of tracing something and then making it into an audio signal. For me, it's really a sort of simple, aesthetically pleasing relationship. For me, it seems very direct. It's not very artificial. And there's one relationship I discovered which still amazes me, which I want to show you. Which is, most people, of course, are aware that 3D printing is a thing. And if you think about 3D printing, right, you have this thing where you have this tool and the tool moves around. And so this is something I want to demo you really quick.
So I need to find, and I hope I succeed, some 3D model, a random 3D model on my computer. So let's look for .obj files. And those are probably not ones. Where is everything? Okay, so I know I should have some in here. This is 3D print folder, and there should be some. Ah, there's STLs. Good. So I don't know. Let's see what this one is. Okay, so it's a vase. It's a vase, and I'm gonna make it a little bit smaller. And in 3D printing now you can click. You do the slicing. So this is how it works for those who haven't 3D printed. And then it sort of shows you how it's gonna move. So because it needs to extrude from a single piece of filament this shape, and you have a million settings in this program. So I can select, for instance, how it's gonna make the bottom and the top. So let's change these settings a little bit and slice again. So now we get this really neat pattern. And to be able to show the effect a little bit more, I'm gonna make it even smaller, so it's less complicated. Oh, I think I made it too small. I think okay, so let's try again. Okay, let's try again, and let's export this. So let's export the G code, and that's fine. And let's look into the file. So if you open this file, it's really just a text file. And the text file you copy to the printer, and then the printer blindly follows these commands. And what those commands are they're just coordinates, and they tell the tool where to go. So for instance, with the vase, it's gonna have a million little points around the outline, and then the printer connects the points. And then it does the infill, and then it moves up to the layer. So I got into 3D printing. Of course, this was my first thought, is like, oh, that's music. So I'm gonna show you this. So this is the program that I developed to be able to sort of tackle this music. And I don't want to show it too much because I'm selling it, and I don't want to make it a sales show. But so I added support, and it's going to be a harsh sound for a second maybe. We used the wrong device. I want the mode to... Do we get something? Okay, so that's the whole mess, and it sounds crazy, but let's look at only a tiny part of this. So you can see this is where the 3D printer starts, and it goes here, and then it does a little dot, and then it moves to the center, and it starts doing the shape. So I'm gonna make it show a little bit less, and so now let's move through the model as it would print, and so to me this is really interesting that you have this sort of automatically every 3D print is a song. You can't help it. So this is not the very interesting one because it's a bass and it just goes up. But you can play with the shapes, and then usually during the concerts I will play one song from like a 3D model. So it's this kind of relationships that I really like. So that's sort of the title that explains the title of the talk for me, at least. Like every squiggle, everything that's somehow drawn, and it doesn't matter if it's you or a machine, like automatically you can look at it as music in one way or the other. Okay, time-wise, I think it's very much time for questions. Yeah, I'm gonna skip the last two. parts. Other questions even? Okay, so let's just, I mean, I could go on forever, but let's just end it early, and if questions, yes.
I've got a question. I mean, it looks really cool.
Uh-huh.
Is there anyone, yourself or anybody else, using hardware like that in a live performance setting? Is that people using this?
Yes. I mean, so for instance, Matthias does performances with this. And this would be my last slide, which is who else does this and where do you look? So there's this website oscilloscopemusic.com. That's Chris and I. So we're not part of an institute or something. So we try to sort of sell our stuff. And we also run a little subreddit where people can ask questions, and there's a little community, so you get some help how to get started. There's Chris Allen, who's a Canadian, and he makes a lot of music. He's also enjoys his fair share of success, and he's also in sort of really into this like 3D modeling aspect. So he makes this plugin that removes the hidden edges. It's a specific problem that comes up. There's Derek Holzer, which looks at it way more from the visual perspective. He doesn't care so much about the sound, but he really looks at it from an art background. He has a pure data library, so if you know pure data, that's probably of the biggest interest to you. And he also runs a Facebook group, Vector Synthesis, where you can ask questions. And I know I'm going fast. There's Ted Davis. He teaches in Zurich. And he makes a processing library. So if you're into processing, you might want to look at this. It's called XY Scope. And also, I mean, you can see this with all these things. It works with oscilloscopes and lasers. It's also true for all the others. It's just because the devices are so similar. And finally, there's, since 2018 was the first time, a festival dedicated to this, which is called the Vector Hack Festival. And it brings in, I would say, a little bit more. It widens the scope even a bit into analog computing and other things, but it's all based around people who use this output device still in the year 2021. So I made this list, and I'm gonna leave it open. That's all the links. If someone got very curious and you want to just try the program, because I know I'm selling it, please contact Matthias and he will let me know, and I will just give you an access code and you can try it out. Okay, that answers the question, I guess.
I have two questions. First one is very simple technical question. I think there are analog and also digital oscilloscopes. Is there any difference in the function, you would say? These kind of work better with analog? Or
say you're an electronics person and you want to do day-to-day work. You want really to use the digital oscilloscope because it can store everything and it can do a million automatic calculations on your data. Like it can tell you how wide apart it is and the frequency, but way more. It can decode signals and everything. So you work as an electronics engineer, you will use a digital oscilloscope. The problem is they don't really pay much attention to the aesthetic of the output. The tube oscilloscope has this advantage that, first of all, the way it works is there's a layer of phosphorus. Okay, so I'm gonna explain this because it's quite beautiful actually. Also, how simple this instrument is in theory. In practice, it's of course hard, but in theory, it's simple. So if you look at this, you cut it along the side. It looks like this. So it's always this shape, and a very long and there's two plates, one top, one bottom, and then the same, there's one to the left and to the right of this, and they basically go into an amplifier, and it's the left input there, and this goes into an amplifier, and you put the right input here, and then here there's it's called a gun. So this fires electrons, a steady stream, and these plates are sort of like a capacitor, so they deflect the electrons, they bend them. So if you apply a voltage here, it will sort of bend upwards and then hit the screen somewhere. And here is a layer of phosphorus, and this will glow for a little while. So what just the design of this has in itself is if you move the dot fast, it will sort of have this afterglow, and it's really a beautiful aesthetic, because if you go slow in certain parts and fast in other parts, you will really see this dynamic of this shape. And I've invested many hours into simulating this device. So I have, for instance, you can find this on my GitHub account. It's just called oscilloscope, where I try to simulate. Let's see what this is. None of these work, but I'll show you with one of the files we had. Let's lose this one. Oh, I think I broke it, but never mind. There's a simulator, and I invested a lot of time, and it's really tricky to simulate what's going on. There's so many edge cases. So, for instance, right now, when the dot is standing still, maybe you're too far to see, but you have this dot, and you have this beautiful sort of corona ring around it. Sorry. Not to offend anyone. And as you start moving it, like this starts to dissipate in really interesting ways, and I think the aesthetic is nice, and that's the reason. So we'll give one last thing to drive the point home. If you do this, so you go very slow here and then very fast here. On a digital oscilloscope, you will just get a line, and you won't see the difference. On an analog oscilloscope, you will see a very thick line here, and it will thin out beautifully here. Yeah, it's just nicer.
Okay. And the second question was, when you were talking earlier about Finger Baby, I was reminded of when I started to deal a bit with electronic instruments from the 70s. I was very fascinated about this aspect that these instruments suddenly gave a lot of people who could afford it, obviously, the chance to really investigate in sound and explore sound, experiment with sound, without having had a classical music education or a classical music background. And you also said you don't know how to play the piano, but still you work with sound. And so I think these instruments, like electronic instruments, have very political dimension also through this, because it sort of opens up this field of sound investigation to a lot of people. And I was just wondering if that is also an inspiration to you, or if that
Yeah, I mean, I think I would sum it up as like sort of the democratization, it's often called. Yeah, I think there's an interesting conflict there always, because for instance, what interests me is like making this, but then someone using this program doesn't care about making the program. So that's a conflict of interest, but we sort of depend on each other. I don't know, I think I don't have a big point to make about this. The effect is clear, it exists, and it's observable everywhere, not just in music. I think sometimes it's problematic, sometimes it's not. I think in the case of music it's not. It's
way to spend some free time. I think with other things it's problematic, like flying. We want to democratize, like it has, you know, these implications. But with music, I don't see an issue. I think it's good. Enjoy everyone, like no matter how. Okay, I'm sorry. I promised too much about the break. Okay, so we end this. Thanks again for being invited.